Okay, so let's start by looking at some of the basic commands for Cadence genus. So after I've entered into my genus directory, I'll start loading the library file. Again, I'm using slow.lib for this purpose. Afterwards, I need to load the path for my Verilog file. Again, I'm using a 48-bit counter as an example. So here. Afterwards, I need to elaborate my design with the name of the top module of my Verilog file that I'm using here. Afterwards, I need to read the design constraints. So both create clock and get port commands are successfully created. Afterwards, I need to synthesize my design, for which I'll be using this command. Once it's synthesized, I need to generate the netlist. So the netlist is generated. Afterwards, I need to check design if there are any DRC errors or something. So there are right now no errors in this particular module that I'm checking. So there are various factors which we can check for our loaded design. Let's start with the area one. It tells you how much area each cell in your design is occupying. Here I'll reduce the size a bit. Yeah, so this is the total area count that your design is taking right now. I'm simulating this at around 200 megahertz. So at 200 megahertz, this is the total area consumed by your design, and this is the cell count. Afterwards, we can check the power as well, for which the command is report_power. So again, this is the number of cells, this is the leakage power, this is the dynamic power, and this is the total power in terms of nanowatt that your design is consuming. Afterwards, we have something called as report timing. I have already made a separate video for this report timing, how to analyze T clock frequency and the slack. So I'll proceed further. Afterwards, we can also check the clock gating. This reports your clock gating in design. Right now my design doesn't have any clock gating, so it shows something like this. Afterwards, you can check how many gates and which type of gates are used to implement your design. I have written a behavioral code, so let's see how genus executes it. So these type of gates are present in the tech library, and these many number of times are these gates from the tech library are used, and this is their area contribution, and this is the library from which they are calling this tech library. And you can also see type of elements like sequential, inverter, and all, how many types of elements are used. So this was all about today. Thank you.